Hello, everyone. My name is Chauntée Pitts, and I am the Learning and Development Specialist for STEM Education Works. I was formerly an educator. I taught kindergarten through 5th grade STEM in Texas, and then I also was a middle school teacher in North Carolina, and then a 5th grade teacher in Virginia. So I've been kind of hopped around for a little bit, and now I currently reside in Indiana, Lafayette, which is next to Purdue University. If you know what that is, that's where I'm at. So thank you so much for joining today. I know this is the end of the school year for a lot of y'all, or close to the end, so you're wrapping up. There's a lot of stuff going on. So thank you so much for joining. We're going to talk through some key concepts of just starting with 3D printing. I just want to talk you through the basics of it, talk through just some concepts and some applications, and hopefully by the time we leave here, you'll feel a little bit more confident on how to possibly implement some of this in your classroom. Feel free to ask questions. Just write them in the chat. We'll try to address it at the end. But yeah, I'm really excited to share with you. Just know I'm not a pro at all of this, but I've been doing it for a few years now. And I'm like, okay, I remember how it felt to start and how scary it was to get started. And so hopefully this will help you feel a little more confident. So let's do this. All right. We are going to get started by first talking about what is 3D printing. So if you don't know what it is, just a basic concept of it, it is an additive process. So it is layer by layer created. So it's running it by layers like this as it adds to. So it is an additive, which there's also something called a subtractive, which we're going to look at, which is different. There's two different types of ways that people use this type of printing, 3D printing, which is additive, and then we have subtractive, which is like this. So if you see subtractive, it's usually you put a material in there and let's use the right words. It carves it down to whatever you're asking it to make instead of building from zero up. So that's the difference between the two. Just in case you were curious, that's what that looks like. Oftentimes that a lot of manufacturing use both of these. So yeah, that's subtractive. Anyways, so what's the purpose of this? Why would I want to use that? Of course, everyone's going to tell you all the good reasons why you should use something if they're talking about it. But I will say it is something that I feel like is really good to be using in a classroom full of just lots of types of learners. There's something for everyone, even if each student has their own thing to contribute, that even if it's someone who might be struggling in education as a whole. So it's creativity is really a big part of it, innovation. There's a lot of collaboration and communication that happens, problem solving, critical thinking. And honestly, it does build confidence. The more that I feel like for me, even the more I did things and started to realize, oh, I fixed that. Oh, I know how to fix that. It built up to something where I felt a lot more confident and feeling comfortable enough at least to talk about it on a webinar. So that's the gist of it for me. And I feel like with students, this type of activity, it gives everybody a chance to kind of take what they're learning and apply it in their own way of how they're seeing things. And we'll get more into that as we go along, but that's how I feel about it. And of course, everyone has different opinions on different STEM activities and how to bring them into the classroom and implementation of that. So everyone has a different view of that, but that's how I feel about it. So what is Tinkercad? Because that's where we're going to start. And I will show you some other platforms that are really good to use. But so there's a lot of things that I feel like you could use depending on your level, but I feel like Tinkercad is one of the best as far as user-friendly and especially for all different ages of students. So yeah, that's what it is. So it's a cloud-based. That's one thing I do love about it. It doesn't matter what kind of technology you're using on to edit and create. It can be used on anything that has access to online. So, which is really nice because no matter what you're using, whether it's a Chromebook or you have laptops, a different type of laptop, or you have desktops, you can use it any of those. I've seen people use it on iPads. It's a little more difficult on an iPad, but if you're just doing basic, it's pretty easy. So we're going to get into Tinkercad. Before I do that, I want to tell you what I'm going to show you. So I'm going to show you where to access tutorials so that you can also learn how to go through that. I'm going to show you some concepts of creating a design just to show you that concept of that. I'm going to introduce you to Thingiverse. If you've never heard of Thingiverse, it is a really cool website that's free. I will give you some caution with it when I get to that, but I use it often. And then also just what does it look like to upload a design? And it doesn't matter what kind of 3D printer you're using, this can be used for any of it, which is one of the biggest things for me that stood out. It's like, okay, I can use this no matter what, which there's a lot of programs like this. This to me is a base model. It is an intro. There are things that I use with middle school and upper grade levels that I think are better for that. And I will show you what those are. If you're like, my kids would fly through this and this is not probably going to be a thing we want to use, I will show you some other free websites that I think are really good. So without further ado, we're going to get started with Tinkercad. If you have a computer with you and you want to do this with me, great. That's why I'm going to give you a chance to, I'm showing you this. If you want to join it, I'm going to have someone put the link in there for you as well. If you want to go and do it with me, there is going to be a recording of this that's going to get sent out to you after this. So if you want to just watch for now and use it later, totally fine. It's up to you how you want to do it. So what I'm going to do is go to Tinkercad. So it is tinkercad.com. It is through AutoCAD or Autodesk. So if you've heard of Autodesk, this is the same company that owns it. I am going to show you. So there's a sign up and you can just sign up as an educator if you were going to sign up. And then you can log in with Google or whatever you want to. I'm just going to log in real quick as an educator, sign in with my Google just like that. When I get here, I'm going to click my Google account and hopefully it loads. In a perfect world, we're going to go back. So here we go. Let's try that again. Watch my internet decide today's not the day. Nope, here we go. Okay, good. Whew. I was worried there for a second. Okay, so now we're in the main page. This is a lot. You're going to see a lot on here because I do a lot of playing around on it, but pretend there's nothing on the screen. The top of this area, there's a lot of resources and things there. Under resources, there's something there called the Learning Center. When I tell you that is the best way to learn anything on Tinkercad, I mean that. I have learned so much that I was like, oh, I didn't even know it could do that just from trying it out. So I'm going to click that just to show you the concept of it. So all kinds of Learn 3D design stuff on here. When I view all, I can literally see, how do I even place something on the bed? How do I view it? All of that is here for you. And this, you can do it on your own. You can also assign it to your class, and I will show you how to set up a class in a second, but you'll be able to assign it to your class, and then your students are able to walk through this themselves and probably get ahead of us, which is usually what happens, at least in my experience. I'm like, oh yeah, I'm going to show you this cool new thing that I'm learning. And they're like, oh yeah, we've accomplished it already. So yeah, but there's lots and lots of stuff on here that walks them through even just activities itself. But this area right here, I would say is probably the thing I use the most when I first get started, because I can just go there as a teacher and log in there and play with it. Just so you're aware, the logo is the best way to go back to your main page. So I always just click the logo and it takes me back to here. Within here, you have something where you have a create or a new. When I click that, it'll ask me what type. It does have circuitry on here that you can use. That's also free, and also code blocks for block coding. I don't use either of these because I have a better platform that I like to use for those particular things, but I definitely know of people who use those and love it. So that's there. But I'm going to click, for the sake of this, 3D design. It's going to take us to that build plate. This right here, that middle place, is what represents the build plate, like what's on your 3D printer. So if you're new to 3D printers, I just want to clarify that. So this is the base space that the kids will work on. Over on the right-hand side, tons and tons of already created shapes. This is what differs between Tinkercad and other platforms. AutoCAD and places like that, they have it where the kids are actually telling the computer, I want something that's this size, this dimension, all of that. They're entering it in themselves. But for younger kids, that can be really intimidating. And those of us who haven't done 3D printing before, can be intimidating. So they have stuff already created. So if I click on, let's say, this cylinder, when I click the cylinder, it now is on my mouse and I can drop it anywhere I want on the build plate. That allows for our students to take shapes and combine them and create their own kind of view, or own kind of design. So this right here is just me stacking shapes and creating something, which is, to me, a great way for especially elementary students when you're trying to teach 3D, the concept of 3D shapes, which is usually kind of difficult, allowing them a chance to actually be able to see it. This up here allows you to look around at different angles. They can see how it's sitting on the bed and whether or not it's the right look that they're looking for. And they can hit this little home button and it takes it back to that main page. In here, this is just the basic shape area. It also has a text thing on there. So when I click text, I can lay the text where I want to and then type in any word I want to. And I'm just going to type in my last name for this purpose. But you can type in whatever you would like and then add as much as you want, combine it however you want to. The students really enjoy this concept of like getting to click and drag, but also there's not just shapes over here. There's all kinds of stuff like fun and games, different objects. You have vehicles, creatures, all kinds of things that are already created. So if I click like creatures and characters, you'll see here that there's all kinds of stuff to go with creatures and characters. One activity I've done with my kids is I've had them build a Funko Pop, and it was really fun to see what they click and build from that. It's a lot of fun. So that's what I've used these things for. But you can also search for things, and if there's something there, the kids can pull that from there as well. But this is what, again, the way that I have started out with anybody is just letting them have a chance to play around with what's here and just add to the build plate. I don't initially tell the kids we're going to print it until later, because I like for them to just explore what it looks like to design. And it is a lot of fun to watch them come up with things that you're like, I didn't even know I could do that, because that happens as well. I know if you're an educator, you know what that looks like. Anyways, so there is a lot, like I said, of concepts as you play around with this that will come to light. So when I click here, you'll see there's this little cube thing here, or nope, that's not the word I'm looking for, but we're not even going to try anymore. Anyways, when I click that, I can raise and lower. It's a triangle. There we go. I can raise and lower it. That's how I raise and lower it. You can see that that would be a little bit frustrating if you're using an iPad, but it's doable. You also see here where you can rotate it when you see that little angle there. So when I click on this design, you'll see those different little arrows. That's showing you how you can turn it. So I can turn it this way, or I can turn it the other way. I'm going to get rid of this for the sake of seeing. Here's the part that I personally got really frustrated with because I didn't understand why it was doing that. But you'll notice that these little tick marks, that's how it jumps. And I'm like, I don't want it to turn that much. And it frustrated me a lot. What I didn't realize is if you move your mouse up where it's not inside of this area, then it lights up and it lets you do slow rotations, which is a game changer when you're trying to make little rotations. You can see the shadow underneath there, so you know that it's above the build plate, and that helps the kids be able to visually see if it's not working correctly. Tinkercad is compatible with iPads, as long as you have a platform. Now, iPads are a little bit more difficult, like I said, especially when I'm trying to reach size stuff. You'll notice if I click the side, it kind of changes the shape, not just the size. You have to hold down Shift for that. And so with an iPad, it makes it a little bit difficult. Anyways, so this is the concept. Usually when I start out with the kids, I ask them to just make a name tag, which is just like get a blank shape, flatten it however you want to, raise or flatten it how you want to, and then add your text to it and make yourself a little name tag for your desk. Simple task, not too complex, but a way for them to start exploring. Anyways, so that's the concept of Tinkercad. Again, I'm not going to get super deep into it because we have a very short time frame of this, but I wanted to show you some of the things that I personally like to use or explore with, or things I have been frustrated with. There is a thing here where it shows this little scribble. If I click that, I'm actually able to click and then draw what I want it to be. And then when I hit done, that will actually go onto the build plate, and then I can reshape and use that. So if you have an iPad, that one to me is a lot better when it comes to drawing it out, because it's a little easier than holding a mouse and pushing a mouse, especially a lot of kids are not used to using a mouse. Those of us who are older, we know what it's like. But anyway, we won't go there. So yes, so basically the concept of this is to get the kids excited about and learning about just the basics of CAD. They're not really using CAD fully, but that's what that looks like. If they're done with it, they can import it or export it out. And that's the part where I always say, make sure that you're talking about and understanding what the file needs to be. If you're going to convert it to your printer, it needs to be an STL file. STL is a 3D printing file, but it's not coded yet for your actual printer. There are some printers that will print STL, but they're not as common as the people who have their own software. You have to run it through their software and create a code. It's really important that you know that, because if you save it as an STL, which absolutely you should, and then you try to save it onto a drive or put it onto your printer, it's not necessarily going to work because it's not made for a footprint for your actual 3D printer. And what I mean by that is whatever software, or if I use MakerBot, so I'm going to use them, but I go to MakerBot's website and I go to their cloud print. I put that image onto the cloud print, and then I transfer it into a G code. G code is the thing that you need to have for your printer. A G code is a non-editable file that is already created into a layer, and that is what is used on the printers. It's really frustrating at first because you're like, STL should be for everything. I don't disagree. Yay. And I'm really happy. People, if you have your favorite type printers or whatever you're using, please feel free to put that in the chat. I use MakerBot. Our company uses MakerBot. I love them. They just coming up with a new one, but yeah, there's lots of stuff out there, and you really need to know what it is you're looking for your environment, because that's the biggest thing for me. I make sure that mine are enclosed because I don't trust them. My students aren't going to try to put their hands under it or touch stuff. But if you're working with older students who are not doing that, great. Anyway, so G-code is that file that is uneditable and is the file you need to use to put onto your 3D printer. That's the difference between them. STL is a 3D file that can be edited still. So once you do that, you can upload that file to that platform that you're using for your printers. Okay, so I'm going to go back to my main page for a quick second. Again, you just click the logo. It should take you back. Once I'm there, I'm going to kind of show you just real quickly the classes. So when I click classes, this is where I can create my class. If you click there and it says join a class, that means that you're not signed in as an educator. You're signed in, even I've done it before where I've signed in as an educator and it still kicked me off. So I want to clarify that for you. If it doesn't show up as create a class and it shows join a class, you'll click your little logo face at the top and hit settings, and you have to scroll down. Nope. Oh yeah, to your role. And there you'll click teacher if it's not selected. Once you do that, when you click back to that main page and then go to your classes, it should show you there that you can now create a class. I'm only telling you that because I ran into an issue and I was like, why am I signed up as a teacher? I don't understand. Sometimes it does it, sometimes it doesn't. All right, so once I'm in here and I'm set up to ready to create a class, I can create a new class, call it whatever I want, select the grade. Again, I've done others. Some of them don't fit what I need. Subject, it doesn't really matter. It's just a matter of just keeping it separate for your own sake. You have class safe mode. I leave it on. I create the class and it will pop up in there. And now I can share the link out with my students. Or you can also upload a class roster. So I can add it that way. So if I hit add students, I can type it in, which I would have no desire to do personally. But if it's a thing you like to do, where you type in every student, by all means. But you can also paste a list of students. So if you have your roster, you can just copy and paste it on there and it will create their accounts. So when they click on your class, their name will already be in there. But you can also do it a different way. So it's up to you how you want to do it. Once you have your class in there, this is the part where I get very excited. So I'm gonna try to talk slower. I know I talk fast and I'm so sorry. But this is where I really like it, because oftentimes the biggest thing that I run into with doing 3D printing is that my students don't really know where to start. So you can actually, as the teacher, go in and create an activity. I'm going to, again, call it test. Usually I just run my finger across the keyboard, but we're going to keep it right this time. Create activity. Once I do that, I can click, sorry, I went fast, my bad. Once I create a new activity, I can click that activity, then go in there and create a new design. And I can actually make it where when my students click on that activity and they go to their build plate, there's already a design there that they're building off of. And that's how I've done Funko Pops, is that I have gone and found a Funko Pop, which I'm going to show you how to do in just a second, and then uploaded it to here. So that's what we're going to do just for the sake of learning. I've gone to this website and just gotten like blank stuff. For instance, like a Pez dispenser, the bottom of one, and I had the kids create the top of that, which I have a lesson that I'm going to show you in a minute. So what we're going to do is go to that website really quick. So it's called thingiverse.com. This website has free, for anybody, files and designs that people have made and just uploaded on there. It is like a plethora, and there's everything under the sun. And when I say everything under the sun, I do mean everything, including weapons, anything else under there. So I don't usually give the kids access to it, but just know if you do, they're going to be able to find anything that might not all be school appropriate. So just, that's your warning. So for the sake of that though, I'm going to put Funko Pop, and then I'm going to put, I think I put DIY is what I did. And then it popped up as a blank one. Hopefully. There it is. Yeah. So I'm going to click that design. Of course, because it's free, there'll be lots of ads that pop up. That's another thing that you have to bear with. But once you get there, it'll show you the design. If you scroll down, a lot of people have on here a summary of like, did they use rafts? Did they use supports? What kind of infill? And they kind of give you like the directions to what you need to copy, which is super nice because sometimes we don't know. And it's nice for someone who's made it to say, this is how you do it. Then I can click on files. I can download that file, and it's automatically going to download. And I think I already had it, but that's okay. And I'm going to save that to my desktop. I'm going to scroll up for a second because I do want to show y'all. If I click on comments, there are people that write in there that they've tried it and maybe something that didn't work, something that did work, or maybe they're like, hey, you should do it this way. It's helpful. Sometimes people do that. And then also people will put, if they made it, they'll show kind of what they've made on there. So you can see some finished products as well. So I've downloaded that file. That's all you have to do on this page. If you're like, I just don't want to do anything to the file, I just want to print it, one that I found on here, which you can find. I don't care what you like. If you type it in, there's probably something there for you. Harry Potter, Star Wars, all the nerd things that are going to come out of my head. Marvel, you know, the things I like, those are all on there. So search away, enjoy every moment of it. There's so much. And again, it's free. You can just go crazy. But I'm going to go back to my classroom. So I'm going to say I'm doing this Funko Pop activity, right? I'm going to hit import. You can do that with any file you want. If you have an STL file, you can upload that file onto this design or classroom. And then now when the kids click on that activity, that now is allowed for them to start editing and creating their own. And every single kid will get that on their build plate once they log in to your classroom. So I'm going to click choose a file. I'm going to click Funko, hit open, and then I'm going to import it onto my bed. This might take a second. So while I do that, I'm just checking to make sure there's no questions. And I don't think I have any, but if you do have some, feel free to ask. I also will say, again, I've done this with different levels, and it looks differently with different classes. And we all know once we get comfortable, the next class that comes in isn't like the class last year, and you have to redo the game. So I definitely understand that part of it. So anyway, this is the concept that I started with my younger kids, especially, where I would just go to the Thingiverse, find something that I want my students to build off of or add to. I will say, I've told my students, see how ridiculously big this is. I've told my students that if you are going to use something that's already been created, then you need to make sure that you make a certain amount of changes to it. Otherwise, it's not your design. You're just taking someone else's and making it. And that's been a conversation that we've had many times where I've had to say, yeah, that's not your design. That's somebody else's. Because like, look what I made. Well, no, probably not. Anyway, so then you can resize it. If I hit the home button, it'll show me back where it was. I can turn him around, or I can leave him this way, whatever. And then now if I leave out, which I'm just going to do for the sake of this activity, I'm going to leave where I am and go back to my design. Here it is, there and ready to go. You can tinker it as much as you want to. So if you want to add stuff to it after you've done it, you're like, oh, this is what I should have done with it. You still can go back and add it. But click those three dots and I can say duplicate or edit. But if I'm good with it, I'm good with it. Now it's in my classroom. Now my students have it. If you want to add it to another class, you can. So like I added it just to this one class because I was playing with it. But I can say copy to classes and it'll pop up all my classes that I have and I can select every single one I want to have this activity. So you can pick and choose who gets it and who doesn't. But that's really helpful, at least it was for me, when it comes to trying to create an activity or like, where do I start? You can start with just putting a blank name tag thing on there and they add their name. And again, it's just getting them used to how to use this and the design with it. Okay, so that's the concept of that. Also, just a quick note that co-teachers are on here. And if you want to add co-teachers, you can add co-teachers to it. So if you want some of your other teachers, if you're working with other groups, you can add them to it as well. So when I click co-teaching on here, I can invite them into that. All right, so that's the classes. I'm going to double check. So if you don't have a budget for a 3D printer, there's two things I want to say because that is something that I feel like is hard to get. Teaching them how to do 3D like CAD is already a trial. And that's why I say don't even start with a 3D printer initially. Just start with teaching them that whole entire concept of creating on CAD. To me, that's valuable even if you don't 3D print because then they can apply that later on when they're in middle and high school. But it gives them an idea of how to design. Okay, so also on here, you can see under resources, I was going to quickly show you, there's the Learning Center, which is where the tutorials are. If you missed that, that's the place you want to go to start. There's a blog that you can comment and read up on things that people are messing around with. There are free lesson plans also on there for you. You can design and make different things. There are challenges also that I really like. So if you are like, I don't know what to do with my students, they have challenges they put up and they'll give you end dates of when it closes and they can submit to these challenges and it can just be a thing that you do through that. They have old ones they keep up even though they're closed and you can't actually send in to the company, you can still do the activities there. There's a gallery, just like what Tinkercad is like. This is on, just like Thingiverse is on. The two letters the same. It's getting me. Sorry. Okay, so Tinkercad has that same thing as Thingiverse, where I can then search and just type in, let's say if I wanted to do like name tag or nameplate, maybe is the best word. I can type that in and then it will pull up everything that somebody has shared and created, all different types of ones. I can also select that and copy and tinker it myself. Now I've had a copy of someone else's stuff, which is just the same concept that we did from Thingiverse. It's just a different approach. That's also really helpful if you're like, I don't know what to do. You can just start looking through what recently has been done and get some ideas from that as well. So Tinkercad, back in here. I showed you classes. I showed you the name tag thing. I'm going to double check, make sure I did uploading a design, which we did. We talked about STL files. We created a design. Cool. Just checking my notes because it's easy for me to not remember stuff. Any questions so far? Because we are going to talk about application, but I wanted to first show you just some basic concepts. If you've used Tinkercad before, sorry. I just feel like it's the best way to start is to kind of show you guys something. Hopefully I showed you something that maybe you don't know or you didn't know before. So great. So what I'm going to do is go back in here, but if you have questions, please feel free to ask them. So we got started with Tinkercad, and now I'm going to just talk about some of the stuff behind 3D printing that is sort of, oh, how do you add it to the class? I'll come back to that because I did it and I can show you again. Give me 1 second. So basically what I do with supports is I use the YHT concept. Again, you have to look at everything the kids create as layers. It's going to get printed in layers and it's going to build off of those layers. So H has that bridge in between. It might not be able to be supported by that. And you might have to put support underneath it to keep it from collapsing on itself. That's the reason that supports are important. So I usually have the kids or I will look at it and say, actually, that can't stand on its own without something holding it up. And that is how that works. It can be easily taken off. And when I say easily, sometimes you do have to use like pliers of some sort to help pull it off because it can be a little bit, the plastic can be a little bit sharp. So just be careful with that, but it should be able to be pulled off sort of like a ribbon. It's kind of exciting. So I love the YHT way because again, I like acronyms and easy tricks because I was a teacher. And as all of us know in teaching, it's like, how can I help kids understand it and me at the same time? And I feel like that's the way to do it. So yeah. So basically, I usually talk to the kids about, okay, if you think about how something prints, like I printed a dinosaur one time and didn't think about the fact that the mouth was open and it collapsed on itself. And I was like, oh my gosh, why wouldn't I have thought of that? Those are the things that are easy to miss because you're not thinking, oh, that's a problem. All right, so some of the components of it, which can get really confusing. So I wanted to help you guys at least understand a little bit of the concept in case you haven't messed with this. There's infill, which is basically what's inside of your print. You can do 100%, which is totally full, all the way full filament, plastic, no hole, or you can do it where it's less and less. It's usually set to 15% as a default. And that's what my printer is set to is default. So how I do it is I usually leave it on 15% unless I'm printing a bunch of small things. And you have to think about how that's going to impact the smaller you make it. So definitely want to keep an eye on that. You increase that infill depending on what you're doing with how small it is or what the design is itself. The layers are basically, I love this idea of thinking as a unique slice of bread. When you stack, it creates a 3D model. And that's basically what's happening. You're measuring that thickness of each layer. That's what we're talking about. So when I say, I want the layer to be this thick or this thick or this thick, it will make a difference on what the print turns out to be. Sometimes we mess with the layer, sometimes we don't. Starting out, all I care about is support, usually when I talk about it with my students, and then I'll start dabbing into the world of, okay, let's look at some of the things that we can alter to make it better. That part of it is a fun concept to talk about. The shell is the outside perimeter. You can make the shell as thick or as thin as you want to as well. So that's what that one does. So if you see where it says like shell, which will be one of the options in the platform, that's what you're messing with. Then you have rafts. Rafts are like my favorite and my worst enemy simultaneously because sometimes things don't stick. If things are not sticking to your print bed, it's really frustrating. And then it just looks like shredded mini wheat, honestly, is what I see. When I walk in, I'm like, oh, I made shredded mini wheat. Great. Love that for me. But sometimes it's just a matter of the bed and the filament head being not quite to the right level, which is, you know, a thing. Yes, I know. It's very annoying. I hate it too. So I would say with raft, I always think about like the picture I have up here. I would never put a raft under a square unless there was some purpose for it to be there, and is a waste of filament also. So you want to consider that. That's absolutely true. Sometimes that filament can be wasted because we're getting carried away on using a raft, even though we don't need it. There's spray out there that I've used that's made for 3D printing that has been great. I wish I had it with me. I should have brought it. But if you're interested, we don't sell it, but I got it from someone who uses it with their MakerBot. And it's been kind of a godsend when things are just not really sticking for some reason. I know people have put down tape and then pulled the tape up and it sticks better for that. But really, honestly, that can be the most annoying is when you're print is not sticking to the bed. Then you have something called overhang and bridges. I brought back the T&H just to show you because we just talked about it. But you have that overhang, and that's that stuff that's standing out on its own, that's not being supported by anything. Then you have a bridge that's connecting two pieces to one another. That's what those are. Usually they might need support if they're longer than 50 millimeters. I can print that H without any support underneath it, as long as it's small enough to be able to support it without needing a bridge. But the longer it gets, the more need for support you're going to need. More support you'll need. There it is. We're good. It's Wednesday. Anyways, so I was going to go back to this real quick. I know I told y'all that I was going to show you some other options besides Tinkercad. If you're like, Tinkercad's really easy, you can see on here that it is the easiest one out there. Honestly, I haven't found any of them easier than that. So again, great way to start. But then you have Onshape is my second favorite. That's the one I use with my middle school and high school kids. It is still education friendly. It's free, which is imperative to me, and also gives the kids a chance to really start dabbling in dimensions and measurements and actual blueprints. So I have kids like learning what a blueprint is and bringing it to life on the screen. It's a lot more complex, but it isn't as scary as it seems. But there's also two other ones. SolidWorks is a really awesome program. I obviously am not going to pay for it when I have a teacher salary, which I know that that's not a thing that you can afford necessarily, but it is a really great platform if you're going to be intense creating 3D printing stuff. Then yes, if you want to get super in depth, that's the platform that I would use. But for the purpose of education, Tinkercad and Onshape, I truly love both of them. And I know Sphero, if you know what Sphero is, like the bolts, they also have something called Blueprint. They use Onshape with their blueprint, and it's really cool the way that they've set that up. I'm a fan myself. Okay. So really quick, I wanted to show you some activities that I've created or our company has created that are super just put together and ready to go for you. If you're interested in that stuff, we have free samples that we'll send out to you to try out. But I wanted to show you some activities just to give you an idea of ways that you can use 3D printing in the classroom. This one is animal adaptation. I basically am having them brainstorm and create an animal tooth for an animal that they've designed. They pick where the habitat is, whether they're a carnivore or an omnivore or an herbivore, and then they have to come up with, based on the knowledge that they gain from learning about the different attributes of these types of animals, they get to design their own teeth. And they create animal teeth for it. They can design the whole animal if they want to, but it's a kind of way to bring to life that science concept that you're trying to teach and making it more fun. There's a rubric that goes with it that I use for grading purposes, but it's a fun activity. This is a fifth grade activity, and I do feel like fourth, fifth, depending on what place you're in. Okay, so now I'm going to show you a middle school one. This one is the kids are designing buttons. They are learning about the fashion world, and they're doing research on what fashion looks like, how it impacts the way that people look and dress and things like that. But they're creating a button that they have to make sure it's considering a style, a type of style they want to do. It has to be functionality. They have to think about the fabric, the season. They do that whole research behind it. And it is a lot of fun. But this is another one. And then I have design briefs that go with them now. I give them a narrative. I'm a big engineer design process curriculum writer. So I like to use the engineering design process for everything I do because I'm a fan. Not everybody likes it, but it's my favorite. So I usually give them a narrative or a real world purpose for what we're doing and then let them go. And that's what the design brief does, is they walk them through the engineering design process. This is part one. We have 2 books for middle school. This is part 1 book. And then part 2 book is the one I was talking about earlier, the Pez dispenser. This one is so fun. I'm not just saying that because I happen to have it, but it is a good lesson, and the kids love them, where you're giving them the bottom part of the Pez dispenser, but they're creating the top part of it. And they get to talk about the different things that have come out, which I love Pez. There's always something for everyone. So it's fun to let them research and look up what's already out there and then come up with their own. I've had kids design their own head and put it on there, like really fun. A lot of fun. And that's that one. And then I've these are ones that I personally made. These are called 3D printing quest cards, but I have them for lots of different technology. But for these, they're just different levels that go up. There's 15 different activities, and each activity offers the students something different to do, but it's kind of self-guided a little more. So if you're doing like an after-school program or some type of like summer thing, or maybe you're in the class and you're like, I just need them to do something else because we finished early. These are great. And I have them for serial bolts, microbits, 3D printing, little bits, and a robotic arm called Dubot. But again, I give them this is like you're a young wizard and you're attending a school of enchantment and they have to make bubble wands. And this is for, obviously it's a level 1, so it's for younger kids, but it gives them a purpose for what they're doing. And then on the back of it, it doesn't give them answers. It just gives them basic concepts. Everyone's asking for cost, and I was hoping my people in the chat were going to get that, but they're not. So that's the one side of things I'm not as up to date on. So give me a second and I will pull up that real quick. I'll go there because I think they're 89, but I don't want to be the one that says that without looking. But with it, just so you know, they okay, perfect. I will copy the link. I'm going to go to it. They have a teacher guide with it that you can turn into full lessons if you want to. I think you put it in there. Yeah, if you go to that link. Thank you, Sarah. I knew you would come through. I was waiting. I thought she would come through. So there's the link for that. Yeah, so you can buy them as a bundle or you can buy them separately, but they're not just the cards. You have a teacher guide, and in the guide, I walk you through how to do this if you don't know what you're doing, to make it so that way if you want to make it a full lesson, or if the kid is like, I don't know what to do, you have prompting questions and things like that go with it. Cool. Thank you. Yeah, sorry about that, y'all. I'm glad Sarah saved me on that. We also I'm throwing this up here just because we happen to be running this special right now. I don't usually talk about this stuff, but I'm putting it up there just to let you know that we do have a bundle happening right now that's like a special that you get $400 off of a classroom bundle, which is 2 printers. These sketches are brand new that MakerBot just released this year, and they are like 4 times as fast as their other ones have been. And so it's huge save for me anyways, because the time is obviously a thing. That's the biggest thing with it, is the time. I have also, just a little caveat, the younger kids, I have had them use 3D pins instead of 3D printers, because that's a better way for them to do more hand-eye coordination things, and also learn how to print without using full-on printers. And those are pretty inexpensive. And I'm a fan of that for the younger kids. All right, we did it. And I went 1 minute over. That's impressive. If you missed some of that, I'm so sorry. I was going to get back to that, but I realized the time went fast. If you missed that, how to add the activity, Virginia, you're going to get a copy of this recording, and I'll make sure that it gets sent to you. Obviously, you will get it, but in there, I do show you how to do it. If you have questions, my email is on there, learn@STEMeducationworks. Feel free to email me any questions you have. Yay. What questions do you have? Is there anything? I know this is very fast-paced and lots of information. I share out everything I have because I believe in giving what I have if I can give. We do have lots of free resources on our website. So if you go to our website, you can see lots of stuff for free. Download free samples of everything I showed you today, so you can try it out without buying it, just to see if it's the right fit for you, or whether or not you want to even look into more of it. That's on our website as well. Cool. I'm gonna stop rambling, which is nice. What questions do you have? Anything that I can answer? Again, I'm not a pro, but I am learning. So hopefully something helped. You can add a Google Classroom directly into Tinkercad class. It's a great question. I have not figured out how to do that yet. I'm hoping that they're going to end up adding that. I haven't seen it yet, but I feel like it's way too big. And a lot of people have been asking that I don't see it not being a thing. But I haven't figured out how to do that. If someone else has done that, please speak up because I have not. I can mess with it for a second while I can double check, but I don't think they did that, which I don't understand because again, as we all know, Google is what everybody uses. Let me go in there and see. Yeah, I really don't think I can. Yeah, because then it's just a paste. You can paste the list and that's it. Sorry. Yeah. Sorry, Carlos. It would be really helpful if they did that, but here we are. Yeah. And then use the class link option to share. Yep. That's also how I would do it personally. I would just do the class link and share it out. It's a little easier. I agree, Tim. Thank you for that. They can. That's correct. Thank you. Absolutely, they can. There are different ways that the students can actually share their designs. They can do it just by downloading it like I showed you, but that's a good point. Thank you. Also. All right, so when I hit export, I can select where I send it, and there's lots of options for that too. If you do have MakerBot, this right here, you can send it straight to the platform and it's already ready to go. Whoops, I did click the wrong thing, sorry. And now y'all probably saw it pop up and are like, why didn't you click it? Yeah, I was distracted. That's why. Okay, it was there. So when I click this, instead of that, I can say share to classroom, which that part is connected to that classroom, or you can send it to a Google Drive. So the kids can say, I want to share it to my classroom, and they can actually put it in their classroom and share it. Thank you for that. That was a good add-on. All right, the nice thing about the class link is then you can see their designs and what work. Yes, that part. So you can actually, in the classroom part of it, you can actually click on the students' names as they're in there. So I'm gonna go back to my classroom. I think I have a homeroom that has names in it. Yep. So in there, if let's say Jane is designing, I can click her name and I can see her stuff on there. Grades for the assignments. Yes, usually I use a rubric, but also I have done it where they do the design briefs. And then through that, I usually say, okay, I'm going to grade it based on like what you're filling in and things like that. But yeah, usually I just use a rubric. I create a rubric for everything. I'm telling you, rubrics are a thing for me. I'm not sure who all uses them or if y'all like them, but I'm a fan. And yes, I'm from Texas. I keep saying y'all, and I'm used to people saying stuff. So sorry. Okay, so I'm going to keep looking. If you have questions, please fire away. Okay, thank you, Paige. I missed yours. I'm so sorry. So in the video earlier, I did show you how to take it to the actual 3D printer, sort of. But once you download that file, you're going to have to find out what 3D printer you have. And then you're going to make sure you have that software. There's some type of platform that printer has associated with the printer that you will then upload your design to. And then from that, I then convert it to a G code. That G code again is you can't edit it. It's a footprint that's there and it will be there forever, hypothetically. So that's the one thing about that. Okay. What else have I missed? Sorry, if I missed your question, it's not on purpose. This is a lot of interaction and I'm very happy about it. So please don't stop. I did miss stuff, I think. Okay. Do the rubrics come with the packs? Yes. Rubrics are a part of if you purchase the curriculum, you'll get the rubrics that go with it. Yes. The high school or the middle school one is design briefs, but there are grading answer keys and stuff that go with it to help you be able to grade stuff with that. I try to give you everything you need. As a former teacher writing curriculum, I'm like, okay, what would I want? Of course, we're all different, but I do try. So if you do try out the activities, please reach out and say, like, I tried this one. I want to know, like, how it goes, what your feedback is, because I will take any feedback I can get. Yes, assigning activities for each group. You can create as many as you want. You can assign them to whatever classes you want. And then it's super simple. hypothetically, of course, because you still have to learn the platform and it can be a little intimidating. But again, the tutorials are going to be your best friend for that. In the tutorials, also, just real quick, since we're talking about that, if you click on one of them, you can add it to a class activity. So if you want the kids to actually be doing the lessons, you can create lessons, say add it to the class activity. You can select what class you want to, and then create new activity. And then now you'll have them doing these tutorials. So that is available. Sorry, I didn't show you all that earlier and I meant to come back. All right. What else? Anything else from the group? Had any issues with student accounts? And oh, I haven't had issues, but that doesn't mean anything. Interesting. I'd be curious to know what issues they are. Yeah, because I mean, I'm sure there are glitches and issues that pop up. Kids find their way into things that we didn't know existed often. So yeah, if you want to email me, I'm fine with that. If you want to email me like, hey, here's some issues I've run into, because I can reach out to other people too and see, because I have a lot of teachers that I interact with that I can collaborate about that issue. Oh, yikes. I didn't think they had access to other people's stuff. Anybody on here know the answer to that? All right. Hopefully they do. Yes, thank you so much for joining. Seriously. Yeah, Virginia, send me an email. I want to see, like, if you can screenshot or tell me what it is. I'll see if I can recreate it and see what it is. Yes, yay. I love that, Paige. Thank you, Bridget. That was very kind of you. Anything else? If not, feel free to leave. Obviously, you don't have to stay if you don't want to. But if you have a question, please let me know. But that's the gist of it, guys. I'll be back. I'm taking a break this summer. There won't be really any webinars, but then I start back up in August. And I have some really cool stuff coming at you for August. So hang tight. Thank you for coming. Seriously. Questions? Please let me know. I'm here to help. If I can help, I would love to. Onshape. So it's a free website. They also have tutorials. Please go play around. I am going to work on an Onshape for next year, like hopefully in the beginning of the year, because I am personally learning it right now more in depth. My email is learn@stemeducationworks.com. That is my email. Are you going to put it in the chat? I'm going to have somebody put it in the chat for you. I mean, I can also. I have the ability to do it myself. But thank you, guys. Seriously, thank you so much for coming. I know it's a busy time of year. You're dedicating some time. I do appreciate it. Thank you for what you do. If you're a teacher, we love you. Please keep doing what you're doing. Please let us know if we can help you in any way. Yeah, go enjoy your summer, please, which we all know you won't because you're going to work, because I know how y'all are. Seriously, though, if I can help in any way, please reach out. And we'll be back in August doing this again. So please come back and see me in August. I have lots of new things coming out. Thank you so much, Shakira. Thank you. That's so nice. All right. If there's nothing else, I'm going to end, but you do have my email, so please feel free to reach out. All right, guys. Happy summer. Please make sure you take time for yourself. That's all I'm going to say. That's it. I'm not going to bring up self-care products and things, but please take care of yourself. All right.